Okay, the next axiom is actually not an axiom, it is a schema. The separation schema is an infinite collection of axioms. For each choice of a formula phi, this produces a new axiom. So having chosen any formula phi, defined and restricted in the ways that we discussed when talking about classes, then we get the following axiom dependent on the choice phi, that the set y exists where y is any element of x such that y satisfies phi, possibly phi contains some constant p if you choose it, but the axiom is essentially that for all choices of set x and object p, the subset of x is what this is. It is a subset of x such that the elements of the subset satisfy the formula phi. That this is something we permit ourselves to call a set. So that essentially we can talk about subsets of given sets that, you know, where all of the elements have this or that property. Now, interestingly, this allows us to define the notion of an intersection. So if you have two sets A and B, we define the intersection to be the collection of, oh, it doesn't really matter, but let's just say Y in A, right? I'll choose A to be the so-called parent set, and the property that I want these elements to have is for them to be elements of B as well. And notice here that my formula phi is this one, and the constant that I'm picking is B. So this is a consequence of one of the axioms that you get out of the separation schema. And it allows you to define the notion of intersection. It's interesting that it does not allow you to define the notion of a union, because we do not necessarily know what universal set the union will live in, so to speak. So if you think about the intersection, I could choose A, or just as arbitrarily, I could choose B to be the parent set inside of which the intersection lives. But for the union, if I have a set A and a set B, and I do not as yet have any axiom guaranteeing the existence of the union of these two sets, then I do not know anything about some kind of universal set within which these two live. And so in defining the set where I have to, essentially declare the universe right here before the colon, I would not necessarily have anything I could put there if I wanted to define the notion of the union. So it's an interesting asymmetry between intersection and union when we typically think of these things as, so similar. So, okay, next axiom on the next video.